Okay, so we're going to learn about prime numbers. Prime numbers is a whole number that is greater than 1 but only has 2 factors, the number 1 and itself. A prime number can only have 2 factors. The only way to get to 5 with multiplication is 1 times 5. Let's use manipulatives to work this problem. There are 11 chairs in the art room. What are different ways that the chairs can be arranged into equal groups? Okay, so first I read the question. Now I'm going to go back and I'm going to underline the important parts. 11 chairs and different ways. Different ways means you need at least 2 ways. You have to show me at least 2 ways to do this. Okay. So we got 11 chairs and we have to put 2 different ways down. So let's see. I could do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so I have 4 here, 4 here, but only 3 here. I have 3 this way, 3 this way, 3 this way, and only 2 here. What does that mean? Let's try a different way. Let's use our factor tree. Okay, so our factor tree is where we write the factors out. Okay, so we know that in order to use a factor tree, it has to be 1, 1 and 11. But what else? If I multiply 2 factors together to get to the product of 11, what else gives me 11? Let's see, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, 2 times 5 is 10, but 2 times 6 is 12. That's more than 11, and 10 is less than 11. So that must mean that the only factors are 1 and 11. So that means that 11, I'm sorry, I went too fast, is a prime number. Composite numbers are numbers that have more than 2 factors. The factors of 12 are 1, 2, 3, 4, 6, and 12. You've got the factor tree drawn out here for you, and you also have the factors at the bottom. So let's use the manipulatives to help us better understand composite numbers. So there are 8 chairs in the art room. What are the different ways that the chairs can be arranged into equal groups? So let's underline the important parts. 8 chairs, different ways, equal groups. Okay, so we have 8 chairs, different ways, equal groups. So different means you have to show at least 2 ways. Okay, so let's show at least 2 ways. So we have 1, 2, 3, 4, and 1, 2, 3, 4. So 2 rows, 4 each. 2 times 4 equals 8. 1, 2, 3, 4. 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so now I'm going to do it a different way. 1, 2, 1, 2, 1, 2, and 1, 2. So let's count these. 2, 4, 6, 8. And that works too. That's a different way. So here is one way, and here is another way. So I showed 8 chairs. We used 2 different ways, and we arranged them into equal groups. Now we're going to do 8 on a factor tree. So we always know that we have 1 and 8. And then let's see, 2 and 4 and 3. Oh, does 3 times anything give you 8? Silly Miss Thorne. No. Okay, so we have 1 and 8, 2 and 4. So does 3 give us 8? 3 times anything? We know 4 times 2 gives us 8. I think that's as high as we can go. So when we're writing out our factors, we're going to do 1. And let's jump so back like that. 1, 2, 4, and 8. And those are the factors for the number 8. Okay, so lots of you I know are thinking, but what about 1? Is it prime? 1 is special. It's not considered prime or composite. It only has one factor, and that is the number 1. It's a lonely number, the number 1. Okay, so now we're going to do some working on this together in our together work.